All right, let's take a look at this problem right here. It says we have a contingency table. We have to fill in the blanks, so let's do that first. So we know all these female boxes have to add to 45. So 45 minus 18, 35, 25, 27, 27 minus 16 is 17 minus 6 would be 11. So that would just be 11 for that one. And then all three of those should add up to 45. Yep, and then let's fill in this one. We know 16 plus whatever goes here is to add to 41. So 41 minus 16 is 31. And then we get 25. All right, and then we know that these three boxes have to add to 55. So 55 minus 14 is 45, 41. Minus 25 is 31, 21. And then 20, and then 16. So I think that adds up to 16. 16 plus 14 is 30. And then 30 plus 25 is 55. So we're good there. Then add these up to get the total. So 18 plus 16 is 28, which is 34. When we add these together, 18 plus 16. And then here, this is going to be 14 plus 11, which is 25. And then I think we're good with everything. So all these boxes we got added up here. So let's just double check everything. So 18 plus 16 plus 11 is 45. 16 plus 25 plus 14, 55. 18 plus 16, 34. 16 plus 25, 41. And 14 plus 11 is 25. Okay. So are the events of being female and preferring the coastline independent events? So we're going to go ahead and answer that question using these steps. So to test whether or not events are independent, we can do the check to see if the probability of F and C is equal to the probability of F times the probability of C. And that's what these steps are all trying to get me to do here. So the probability of F and C, a female and the coastline, would be 18 out of suppose we need the grand total here. So 55 plus 45 is 100, right? So we have female and the coastline would be 18 out of 100 is 0.18. Because it's out of 100, we can just say it's 0.18. All right, let me write that a little nicer than that. All right, and then let's find the probability of F. That's the probability of a female is 45 out of 100, so 0.45. And then the probability of that they're along the coastline would be 34 out of 100 or 0.34. So when you multiply 0.45 times 0.34, we get 0.153. So it says, are these numbers the same? The answer is no, they're not the same. If they are, then F and C are independent. If they are not, then F and C are not independent. So we have not independent. So it's not independent. All right, let's take a look at the next one. It says, find the probability that a person is male, given that the person prefers hiking near lakes and streams. Let M equal being male and L prefers hiking near lakes and streams. What word tells you this is a conditional? So a conditional probability means that a specific condition is met, and that's going to be the word given. So the fact that there's that word given there tells us right off the bat that this is a conditional probability, that word given. So fill in the blanks of what we're looking for here. It says find the probability that a person is male, given that the person prefers hiking. So probability that they're male, given that they prefer hiking. So find P of M given L. So remember, the given is after the bar. So PM of L, and that's going to equal, so now we have to find that on the chart. So we focus in on the given, so we're focusing on the prefers hiking near lakes and streams. So we're focusing just on this right here. And then it says find the probability of M so that they're male. That's 25 out of 41. So that one's going to be 25 out of 41. So again, we focus on what's given, and then probability of a male is a 25 out of 41. Is the sample space for this problem all 100 hikers? It is not. It's the 41 hikers, so it's no, because the bottom number is 41. So 41 who prefer lakes and streams. All right, let's take a look at this problem. This is going back to it. Find the probability the person is female or prefers hiking on mountain peaks. So we're going to do this one using these steps here. So find the probability the person is female. So we go back and going to erase, that's 25 here in the middle. So find the probability that they're female. So we go back to being 45 out of 100 or 0.45. Then find the probability that they prefer mountains. So probability that they prefer mountains is 25 out of 100 or 0.25. Find the probability that they're female and prefer mountains. So find the probability that they're female and prefer mountains would be 11 out of 100 or 0.11. Now I'm going to show you something. When we do this probability of a female or prefers mountains, so this is female or prefers mountains, we can go to the chart, and yes, we can just circle every category. So if 18 plus 16 plus 11, or prefers mountains, so that would be these 14 as well, and just add up these four numbers. So 18 plus 16 is 34, plus 11 is 45, plus 14 is 59. So 18 plus 16 is 34, plus 11 is 45, plus 14 is 59. So it's going to be 0.59 for our answer when it's all said and done. But the way that we can use this information is if we are finding the probability of a female or P, F or P, that's going to equal the probability of female plus the probability of mountains minus the probability of both. And that's because we double counted. So the probability of female is 0.45. Probability that like to hike near mountains is 0.25, minus the probability of both was 0.111 or 0.11. So 45 plus 25 is 70, minus 11 is 59, so it's 0.59. So that formula will work if you want to use that. I just like to circle them on the chart and just make sure not to count something more than once.